Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. My name is Anthony Nathaniel, and in this particular episode of our Crash Mathematics for SS3, we'll be talking matrices. So what's a matrix? A matrix is basically a rectangular array of elements, and those elements could be numbers, it could be letters of the alphabet, and it could be any instance of a phenomenon that you are trying to map out, they are trying to note. These matrices, they are used in various areas of mathematics, in real life applications, and also in computer programming. And today we'll be talking about how to perform operations on matrices. Now, there are different operations that can be carried out in a matrix, but first of all, let's talk about how a matrix is represented. Now, you represent a matrix by calling it according to the number of rows and number of columns it has. What is a row? A row is basically a horizontal array of elements in a matrix, and then a column is a vertical array of elements in a matrix. So basically, when you want to name a matrix, you call it by the row first, then you now call the column. So if you have a matrix A, that matrix A, if matrix A has 10 rows and has 6 columns, you will say matrix A is a 10 by 6 matrix, 10 by 6. So that is how to talk about the name of matrices, of matrices. Now, these matrices, there are different operations that can be carried on them. You can multiply matrices, you can divide, you can subtract, and you can you can add. Yes, you can add them. You can add matrices, you can subtract, you can divide and multiply. Now, but when you are dividing, there's a special process for that, and you make use of the inverse. So we'll be talking about all this, and then at the end of this video, we'll be talking about how to use matrix to solve simultaneous equations. So stick through this video, and so we can see how far we can go with this. Now, first of all, the first operation you want to carry on a matrix is addition. Addition of matrix involves knowing the elements. Now, before you can add a matrix, they must have the same number of rows and the same number of columns. Now, let me represent a matrix. I said a matrix is a rectangular array of elements, right? Now, if we're talking about a 3 by 3 matrix, that would be a matrix that has 3 rows, 1, 2, 3, and then 3 columns, 1, 2, 3. So if I would just give any random matrix. Okay, let me give from the textbook we have a matrix A equals, so we have 2, 4, 3. Now this element, this first element, it has its own name. Now the naming of an element in the matrix is according to the position of that element. For example, this element is on the first row and first column, so this is element 1, 1. So if you want to name it, you can call it element 1, 1, because that's the element on the first row and the first column. Now this one is the element on the second row and first column, that's element 1, 2, or you can just say element 1, 2. So now that is how you name those matrices, and then that naming is also applied when you want to talk about the determinants of matrix, and then you want to make use of the nomenclature, the name of those matrices of those elements. So let's move on. So this will be element 1, 2. This is element 1, 3. This is element 2, 2. Element 2, 3. Element 2, element 3, 3, 2, right? So rather element 3, 3. Now these are the elements of this matrix, and in this particular matrix, it is a 3 by 3 matrix. So if you want to add the matrix to another matrix, for example, if this is matrix A and then we have another matrix B, such that B is equals to the matrix 3, 1, 4 minus 1, 3, 2, 2, 1 minus 1. Now if we want to add, if we were supposed to add these two matrices together, all you need to do is you are going to add the corresponding elements of those matrices. Now before you can add matrices together, they have to have the same number of rows and the same number of columns. So if this one has 3 rows, this one will also have 3 rows. If this has 3 columns, this one also has to have 3 columns. So in other words, they have to be equal. the matrices have to be equal. Now in this case, let's make use of this. Now if we want to add this together, the let's call this a plus b. Now a plus b, that would be the first element on the first row and first column will be added to the element on the first row and first column of both matrices. So that means a plus b equals, so the element on the first row and first row here will be added to the element of the first column, row and first column here. That will be 2 plus 3, that will be 5. The element on the first row second column will be added to the element on the first row second column here. That's 3 plus minus 1, that's 2. So and so on and so forth. 0 plus 2 is 2. 4 plus 1 is 5. 2 plus 3 is 5. 1 plus 1 is 2. 3 plus 4 is 7. 1 plus 2 is 3. Minus 2 plus minus 1 is minus 3. So when you add this matrix together, this is the result. You have a new matrix, and let me cross check my answer here. So this is correct. This is the new matrix, and this matrix is represented as the matrix A plus B. That is how you add matrices together. Now what if we are asked to subtract these matrices? All you need to do, if you are looking for A minus B, in this case A minus B, all you need to do is you subtract the corresponding elements. So the elements on the first row, first column will be subtracted. The elements on the first row, first column here will be subtracted from the elements on the first row, first column here. You get your result. Elements on the first row, second column will be subtracted from the first row, second column here. So third row, first row, third column will be subtracted from first row, third column here, and you get your result. So those are the corresponding elements. So that means what I'm saying is that the order in which they appear is how you subtract them. So when you subtract 3 from 2, which gives minus 1. You subtract minus 1 from 3. That will be 3 minus 1. That's 3 plus 1. That's 4. Then you subtract 2 from 0. That's 0 minus 2. That's minus 2. Then you subtract 1 from 4. That's 4 minus 1. That's 3. You subtract 3 from 2. That's 2 minus 3. That's minus 1. You subtract 1 from 1. That's 1 minus 1. That's 0. You subtract 4 from 3. That's 3 minus 4. That's minus 1. You subtract 2 from 1. That's minus 1. You subtract minus 1 from minus 2. That's minus 2 minus minus 1. So that's minus 2 plus 1. That's minus 1. So if we have to subtract these matrices, that is how it's done. So as you can see, the process of addition of matrices is similar to the process of subtraction of matrices. Now, what if we're asked to find the to multiply a matrix? So there are different types of multiplication. We have when you multiply a matrix by another matrix, and when you multiply a matrix by a scalar. Now a scalar is basically a number. So if you multiply a matrix by a number and you multiply a matrix by another matrix, there are different procedures to it. So first of all let's look for how do we perform a scalar multiplication. So there are two types of multiplication of matrices. There is the scalar multiplication and there's the matrix multiplication. Now let's talk about the scalar multiplication. If A is the matrix 2x y 0. So this is the rectangular array, and you can see that this is a 2 by 2 matrix because it has 2 rows and 2 columns. Now if this is A, then we have to find 3A. Find 3A. Now in this case, when we are looking for 3A, all we need to do is you are going to perform a scalar multiplication. So all you need to do, you multiply and you pre-multiply this matrix by the scalar. So that's when I say pre-multiply, you are going to put that number before the matrix. That means you put the 3 before the matrix. So 3A will be equals to what? You put the 3 first, that's 3 times, then the matrix come after that number. So the matrix here is 2. The element in the first row, first column is 2. First row, second column is x. Second row, first column is y. Second row, second column is 0. So when you pre-multiply a matrix by scalar in this way, so what you are going to do is you are going to multiply every element in that matrix by the scalar. So that would be equals to, our answer will be equals to what? So 3 times 2 is 6. 3 times x is 3x. 3 times y is 3y. 3 times 0 is 0. So you can see that scalar in other words, we multiply every single element in that matrix. So that is how to calculate the scalar multiplication of a matrix. That's simple enough. So now let's go on to matrix multiplication. Now matrix multiplication is very similar to scalar multiplication, but there's a little bit of procedure involved. When we're talking about matrix multiplication, we have to ensure that the number of columns in the first matrix is equal to the number of rows in the second matrix. So for example, if you are multiplying two matrices, this matrix 2 minus 4 and 5, when you are multiplying it with a second matrix minus 3, 7, minus 9 and minus 8. So in this case, you have to make sure that the number of columns in this matrix is equal to the number of rows in this matrix. So let's verify that. So we have here 1, 2, 3, 4 columns. So the number of columns is 4, and then it must be equal to the number of rows. So that means for these two matrices to be able to multiply one another, the number of rows here will have to be 4. So let's verify that. That's 1, 2, 3, 4. So this horizontal array, and there are 4 columns here, 4 rows. So that means these two matrices can multiply each other. So our result will be this. That would be, let's have our answer here. Now 2 times minus 3 is minus 6. 2 times minus 3 is minus 6. That's going to be the result for the first answer. Now 2 times 7 is what? Plus 14. So minus 6 plus 14. Then minus 4 times minus 9 is plus 20 plus 36 plus 36. 5 times minus 8 is minus 40. So when we add everything together, minus 6 plus 14 plus 36 minus 40, that would give us as a result. That would give us at the end of the day we'll get 4. So our answer, we have a 1 by 1 matrix 4. So if you are not sure which kind of matrix you will have, just write the name of the just name the matrix. For the first matrix, this is a 4. This is a 1 by 4 matrix. Then for the second one, this is a 4 by 1 matrix. So the elements in the midpoints, the two the row and the column which match, you circle them out. So you circle them. When you circle them out, what is left? It's the number of rows in the first and the number of columns in the second. So that was just write that out 1 by 1. That means as your answer, your matrix will be a 1 by 1 matrix. So you can see that this matrix here is a 1 by 1 matrix, and we are correct with that procedure. Now, so far we've talked about addition, subtraction, and we've talked about addition, subtraction, and multiplication of matrices. Let's talk about some other things. Now, in these other things we're talking about, let's talk about something that is based on the principles. So we have to talk about the principles before we can move forward. Now, for the principles, we have different things to talk about. For example, we have different types of matrix that we can talk about. We have these matrices, they have their different names. For example, we have the row and column matrix. So if you are looking for a row and column matrix, a row matrix is a matrix. This is a kind of matrix that's a row matrix. This is a column matrix. So anytime it has only vertical, if you have only a single vertical row of if you have only a single vertical column of data, it's called a column matrix. If you have only a single horizontal row of data, it's called a row matrix. So this column matrix and row matrix. Now that was just by the way. That's for the naming of the matrix and for the concept. Now let's talk about different names of matrix. So first of all, we have what's called a null matrix. So a null matrix is also known as a zero matrix. As you can see in this diagram, we have, if any 2 by 2 matrix is pre-multiplied or post-multiplied by the matrix 0, 0, 0, 0, that is the null matrix. It is reduced to the matrix 0, 0, 0, 0. So what that means is that anytime you pre-multiply a matrix by a null matrix, you get a null matrix. So this is analogous to the process of multiplying a number by 0. When you multiply any number by 0, you get 0. So it's the same goes for matrix. A null matrix is like a zero matrix. So anytime you pre-multiply or post-multiply any matrix by 0, by the zero matrix, you get a zero matrix. That is what it's talking about. So and this matrix, this matrix that has all its elements as 0 is called a null or zero matrix. Now let's talk about the next type of matrix we're talking about here, and that would be the identity matrix. The identity matrix is if any 2 by 2 matrix is pre-multiplied or post-multiplied by the matrix 1, 0, 0, 1. So this is a matrix that has the element in the first row, first column is 1, element in the first row, second column is 0, element in the second row, first column is 0, element in the second row, second column is 1. So this is an identity matrix, and anytime you multiply a matrix by this identity matrix, you will get the same matrix. So it's just analogous to multiplying a number by 1. So the identity matrix is like a singular matrix. So when you multiply any number, any matrix by that matrix, you have the initial matrix. So it's an identity matrix, is not a singular matrix. In this case, is I'm just comparing that. Singular matrix, they are different from identity matrix. We'll get to that soon. So, and then let's talk about the determinant of a matrix. Now the determinant of a matrix is gotten if M is a 2 by 2 matrix. The determinant of M, written as absolute M or det M, is given by absolute M equals det M equals the absolute of that matrix. So this is like the absolute notation, but it's represented as equals to AD minus BC. So basically what that means is you are going to be subtracting the second diagonal from the leading diagonal. So this is something that is actually very easy to wrap your head around, and I hope so. So to obtain the determinant of a 2 by 2 matrix, subtract the product of the element in the second diagonal from the product of the element in the leading diagonal. So that is how a 2 by 2 matrix. That's how we get the 2 by 2 matrix. Now let's talk about the next one. Is singular matrix. So for singular matrix, the determinant of a singular matrix is 0. For example, the matrix is singular because the when you look for the determinant, that's when you subtract the product of the second diagonal from the product of the leading diagonal. When you subtract that, you are going to get 0. So anytime the determinant of a matrix is 0, it's called a singular matrix. So next, let's talk about the transpose of a matrix. Now the transpose of a matrix, given any square matrix. So given any square matrix, the transpose of M is formed by interchanging its rows and columns. Thus, if M is the matrix A, B, C, D, then the transpose of M is A, C, B, D. So as you can see on this diagram, so this is how to form the transpose of a matrix. So all you need to do is you change the columns to rows and the rows to columns. So that's how it works. Very simple. And these are the basic concepts you will need to wrap your head around in order to understand matrix. So lastly, let's talk about the inverse of a matrix. Now, the inverse of a matrix, this is basically if you have a matrix, two matrices, and then when you multiply those matrices, if you have an identity matrix as a result, that means this matrix, it doesn't matter the order where you multiply them. So you can say that AB equals I, and I is the identity matrix, and that's equals to BA. So anytime the order of a mathematical operation does not matter, it's called a commutative operation. So it is commutative. So that means when you are looking for the inverse of a matrix, the multiplication of a matrix and its inverse is commutative. So basically, anytime you have a matrix and you multiply them and it gives you an identity matrix, that means that multiplication is commutative. And then B is the inverse of A. So this will tell you that the product of two matrices, the product of a matrix and its inverse is, you give your identity matrix as a result. So the product of AB and BA can be written using A raised to the power minus 1 as A times A raised to the power minus 1 equals I. A raised to the power minus 1 equals A. So that's A raised to the power minus 1 here in this diagram. It is the inverse of the matrix. Now, this is rightly so, and then noting that the leading diagonal of matrix B 3, 2 is obtained by interchanging the top left hand and the bottom right hand element of matrix A. The other diagonal is obtained by multiplying the other two elements of matrix A. So anytime you are looking for the inverse of a matrix, all you need to do is you interchange the element of the leading diagonal, and then you multiply the elements of the second diagonal by minus 1. So that's how it got it. So you can see that for this matrix B, matrix B is like a derived matrix from matrix A. So how you get it is that you interchange the diagonals, as you can see. So when you interchange the diagonals, instead of 2 and 3 as diagonals, you have 3 and 2, and then that's for the leading diagonal. Then for the second diagonal, you multiply every element by minus 1. That means for this 5 and 1, which are elements in the second diagonal, you multiply them by minus 1. That will be minus 5 and minus 1. So as you can see, that is the case. And then at the end of the day, you will still divide by determinant. So you calculate the determinant of that matrix A. So if you can calculate it, that would be 6 minus 5, that's 1. So when you divide by that that determinant, you will get the inverse. So anytime you do that conversion and you divide by the determinant, you get the inverse of the matrix. So as you can see, in general terms, when you have a matrix, if you have a matrix PQRS, if you have a matrix PQRS like this, a matrix PQRS such that PQRS times ACBD equals the identity matrix. So anytime you multiply a matrix and another matrix and it gives you the identity matrix, that means that second matrix is the inverse. And then in general, that means the P equals AD D over AD minus BC. So in general, you can simply represent the inverse of any matrix. Represent the inverse of any matrix as the new matrix, and this new matrix is represented as this on the screen. What you can see on the screen. So that is how you represent the inverse of a matrix. So that's 1 over AD minus BC open bracket D minus C minus B A. So that's the inverse of any matrix A B C D. So this is basically a brushing through of the concepts. These are the basic concepts you will need to understand so that you can be able to wrap your head around the concept of matrices. And then moving on, let's talk about let me give some examples. So now let me give one example here. So in this first example, we'll be looking for the inverse of a matrix. So in this case, when we're looking for the inverse of a matrix, we have the matrix as 3, 4 minus 2 minus 1. So I'll do the example A, and then you can also try the example B and C at your convenience. So but the A, when you're looking for the inverse of a matrix, so as you can see, the determinant of this matrix is the product of the leading diagonal. When you subtract the second diagonal from the leading diagonal, when you subtract that, you get an answer of 11. So its inverse will be equals to 1 over 11 times the matrix, and that matrix will be gotten when you interchange the element. That's the matrix 1, 2, minus 4, and 3. So that's 1, 2, minus 4, and 3. So that will be the inverse. So that means you can also check your answer, as you can see in the example in the screen. So when you check the answer, you multiply them, and then when you multiply them, you are going to get a identity matrix. So that confirms that it is actually the inverse of the matrix. So far so good. You've been able to understand. I hope that you've been able to understand what I've been talking about so far. So finally, in this to wrap up everything I've been talking about matrix, let's talk about an example, how to solve simultaneous equations using matrices. So when you want to solve simultaneous equations using matrices, you make use of the inverse of that matrix. So what you do is you are going to if you have two matrices, two equations, you are going to multiply both sides of the resulting matrix with the inverse of that matrix. So just as we have here. So let's talk about that. Let's solve the equations. So let's solve a particular equations. So we have equations 3x. Solve the equations 3x minus 4y equals 1 and 7x plus y equals 23. So as you can see in this question, what we are going to do is you are going to represent the coefficients of the variables as matrices. So in the first matrix is formed by the coefficient of both x and y in the two equations. That's the matrix 3 minus 4, 7, and 1. Then next we have a column matrix, which is the matrix of the variables. That's column matrix x and y. Then finally on the right hand side we have another column matrix 1 and 23. So this is how you form a simultaneous equation, how you make use of them to form matrices. So as you can see, the determinant of this matrix is 31, and its inverse is equal to 1 over 31 times this new matrix we formed. Don't interchange the leading diagonal. So we interchange the leading diagonal. Instead of 3 and 1, we have 1 and 3. Then for the second diagonal, we are going to multiply them by minus 1. So instead of minus 4 and 7, we have minus 7 and 4 in the elements in the second diagonal. So moving on, so you pre-multiply both sides of equation 1 by this inverse. So as you can see, what that means is that you are going to multiply each of those sides by the inverse, and as you can see, the product of a matrix and its inverse, it is an identity matrix, right? That means that will reduce, the left hand side will reduce at the end of the day, to reduce to the column matrix S, X and Y. Then on the right hand side, when you multiply them, you simply use the concept of multiplication of matrix, which I've talked about. So when you multiply them, you will get your finally you get another column matrix 3 and 2. So when you compare your answers, if two matrices are equal, that means their elements, the corresponding elements will be equal. So the column matrix X and Y will be equal to the column matrix 3 and 2. So as such, X will be equal to 3 and Y equals 2. So that means this will be the solution of this simultaneous equation. So very simple, and voila, we're done. We've gotten the question without even performing much calculations. So this is another method of performing simultaneous equations using the matrix methods. And hopefully you have been able to gain something from this video. I hope that you've been able to gain and improve your knowledge. So hopefully I'll see you in the next episode. Thank you for watching.